expects number values for these parameters. So in my PPT, we have the values. So we want to model our DC motor. Okay, I have not, that parameter window is not available here. Let me check whether that is available in my images. Yeah, it is available in my image. So let me open that. So these are the parameters we want to simulate with. So my inertia of my motor, I want to keep it 0.01. All these are SI units, you can see that. So we are taking SI units as our means unit system, and we are defining the parameters for which we want to do the simulation. So my inertia, I want to keep it J value, I want to keep it 0.01. My motor friction, I want to keep it as 0.1. My conversion constant, you can see normally both the KE KT will be same, so I have simplified it and I have made it as K value, which will be updating as 0.01 once again. And my motor resistance, we are expecting it to keep it as 1 ohm, negligible internal resistance of the coil. And the motor inductance, the coil inductance, we want to update it as 0.5 henries. So these are the values we want to perform the simulation with. Simulink doesn't care about your unit system, it doesn't matter. For Simulink, what is important? The magnitude value of these values. So 0.01, 0.1. These are the values Simulink is expecting right now. So let us update. So how to update this? So we can go back to Simulink environment right now. So I will keep this image window. I will minimize it a little bit so that I can keep it on the side like this. So now what I will do here, I will go to the option called as modeling. You can see on the top, we have so many options in Simulink. Every time you will be in the simulation environment, but right now we are shifting to modeling right now. And I will go to the middle option called as model settings, and in that two options will be there, the model settings and model properties. So every Simulink model will have multiple properties. So now we are interested to access the model properties, Simulink model properties. So we'll open the model properties window like this, and you can see, as I had mentioned, there are so many internal properties are there. But whenever we want to do the simulation, some of the things in the background, whenever the simulation is happening, multiple things will be happening. You can see that you are preloading, you can preload something, post load something. When you are opening the model, when you are simulating the model, when you are starting the simulation, if you are pausing the simulation, if you are releasing the simulation, pause and continuing the simulation, if you are stopping the simulation. So whenever you are doing anything with respect to simulation of a Simulink model, in the background what should happen, I can define. If I want to do something in the background, automatically I can define that. So in my case, what I will do, I will use this function. It is called as init function, initialization function. That means before I start the simulation, I want to initialize certain things. What are those? My system parameters. These are the values that my Simulink has to automatically create. So we will define those values now using this. So we'll go to, callbacks. So init function. So we'll define this. So your J value, if you have seen here, it will be 0.01. Then this is your damping or friction value, so which is 0.1. It doesn't matter what is the unit, it only focuses on the number value. So we are focusing on number here. So then KEKT are conversion constant. So I have updated in my system as K as a common value, because luckily most of the cases it will be common. So it is 0.01. That is the value we have taken. Then this is 1 ohm, that is so resistance of the coil, which in our system we have updated as R. And then 0.5 henries is the coil inductance. So I will update that value 0.5. So update these parameters in the init function. And one more, outside this system, we are also expecting input voltage V. So to define it, why we are doing like this, we can document. So using percentage symbol, how you do in MATLAB script. Basically, we are writing a simple MATLAB script inside here. So these are my motor parameters. All these values are my motor parameters. So this is my motor input. That's it. So we can differentiate what is what. This is my input. Right now maybe I will run the motor with input voltage of 3 volts DC supply, and let's see what will happen. Just 1 minute. ಇದು ಇನ್ನೇನು ಸಿಮ್ಯುಲೇಷನ್ ಆಲ್ಮೋಸ್ಟ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ, ಒಂದು 2 minutes ಮುಗಿಸ್ಬಿಡ್ತೀವಿ. But I normally do like this. I'm showing you. Or if you don't want to do like this, you can copy paste and keep MATLAB script also in the background. You can update these values in workspace. If workspace values are there, it will automatically take it. So that is also possible. Multiple options are there. I normally do like this. I'm showing you my workflow, but multiple options are there. So now if you have updated this, click OK. Now you can see error message will be different. It will not show you what is J, what is I. You will say it is somewhere, it is in the int function, but right now it is not loaded. That is good. That means now problem we have solved. So now we will close this window right now. This is not required for me right now. We'll go back and we'll go back to simulation. Right now let us do 10-second simulation only for our DC motor. We don't worry right now, and we can run the simulation. And in my case it's done. No error, nothing. All the error whatever we had is now cleared up. There is no red color, nothing. And if you see the simulation output, you should get a graph like this. If you are getting a graph like this, we are able to simulate the DC motor. So we can see the speed output. So before your simulation it will be 0, but as you can see, as you are able to excite the DC motor, your speed is transient for certain amount of time. If you calculate the LC time constant value yourself for the value we have taken, you should be able to identify. But you can see in the simulation also it is about 3 seconds, almost very negligible, equal to, not exactly 3 seconds, almost equal to 3 seconds. You can see that time constant of your RC network in the DC motor is around 3 seconds. So not RC, sorry, LC network, RL network, sorry, resistance and inductance. So till that your DC motor speed is transient, and then you can see the motor is having a steady state speed output. So this is the simulation we should get. The idea now, if you want to increase the speed of the motor, increase the voltage, so that is what we can do. So now I can go to the model settings, properties, and if I want to now increase the value, I can increase it here and perform the simulation now. Now the speed will increase. So you can see it has proportionally increased from 0.3 to 0.5.